All right, let's go over the lesson 8 practice problems all over circles. You may have done, because like if we did this in class together, you may have already done this majority of this, so feel free to skip ahead a little bit. And 7 through 14 will be the newer stuff. So if you watched that note video, like the end of it with the bonus content, I would recommend doing that before attempting the rest of this, okay? But this is the big part I want to make sure everyone has down, and the rest of it is just for funsies. Okay, let's look at number 1. Find the following arc measures. All right, so it wants us to find two things in this one, and we know they start pretty easy and then progressively get harder, so let's look at this. It wants us to find the measure of arc JL. Well, okay, from J to L, well, this is a central angle. We know that those are always equal in measure. So if this is 127, this is also 127 degrees. So we'll fill this in over here. Whoa, that's really big. Okay, 127 degrees. Okay, now the second part, they want you to find the measure of arc JML. Let's locate it first very carefully. That means it starts at J, goes through M, and ends up at L. So that's basically the rest of the circle. So we know, like, from here all the way to here is 127. We just want to find the rest of it. So if you remember, the whole circle adds to 360. So we could do 360 minus this part, minus this 127, to give us the remaining part. So let me write down what we're doing. We're doing 360 minus 127. Okay, which I am going to whip out a calculator here. Don't mind if you do the same. 360 minus 127, we get 233 degrees. And that's it for those. Let's look at number 2. Okay, they want us to find the measure of arc BC. Let's locate where that is. Arc BC. Okay, well, they don't give us the angle, so it's not as simple as the other one, so we're going to have to use some of the info they give us right here. Now, this is when I say locate your straight lines and use some prior knowledge. Like, I know I have a straight line right here, and I know part of the angle is 164. Well, remember, a straight line adds up to 180, so if you do 180 minus the 164, that will give you this remaining angle right here. So I recommend doing 180 minus 164 to start. I can write that down, 180 minus 164, and that's going to equal 16. So that little guy right there is 16 degrees, which tells us the measure of arc BC, because this is what we call a central angle. The vertex is at the very center, which means this is the same measure as the angle, this arc. And so that is 16 degrees. Okay, it also wants us to find the measure of arc ABC. And y'all, there are many ways to do these problems. If you do it a different way, but you get the same answer, you go for it. That is totally fine. Okay, arc ABC, let's carefully locate that. Start at A, it wants us to go through B and end at C. All right, so we want to know, basically, we do know the arc from here to here is 16, so that's part of it. We would just need to know the remaining arc from here all the way to here. Now, let's take a look at this. If I let go of that, if this is a straight line going through the center, it's a diameter, then this is half of the circle, so half of 360, which is 180 degrees. So if I kind of highlight that here all the way to here is 180 degrees, then I would just need to add to that this little section right here, which we already said was 16 degrees. So we're going to add 180 plus 16, and that's going to give me 196 degrees. There's so many ways you could do it. You may have thought to, instead of doing that, you could have done, well, I could take all of 360, the whole circle, and subtract off this part we don't need, 164, and you should still get the same thing, 196. We can even double check that. What's 360 minus 164? Press enter. I do get 196. So however you get there, as long as you get the right answer, I'm good with that. Okay, number 3, which does have multiple parts here, so let's get through it. The measure of arc DE. That one's simple enough. We know that's going to be the same as its angle, which they give us, so that is 104 degrees. And like we did over in the notes, it might even be helpful if you want to label the arc, like label things as you go. And you know what? Before I read anything else, sometimes I just like to find parts of the circle. Like my eye goes to this. I notice I have two straight intersecting lines, which creates vertical angles. So I know if this is 104, this is also 104, which means this side's also 104. And I bet somewhere they're going to ask us to find one of those. So I would even label that. I would say, okay, that's 104. Probably highlight this side, also 104. You don't have to do it this way. I just like to do this. Sometimes I will not even look for what they're asking at all. Because if they're asking a bunch of things, I just like to kind of play around with this like it's a puzzle and find all the missing pieces, and then I match it to whichever one they're asking for. Okay, so let's go back to this though. It does want us to find the measure of arc FE. So FE would be from here to here. We don't have that one figured out yet, but we can figure it out by using straight lines. Now there's so many ways you could look at this. You could say, well, this is a straight line, so these two form what's called a linear pair, aka they add up to 180. So we could do 180 minus this 104 to get this part of it, which I recommend doing that. That's going to be the easiest way. And we can write that work if you want to have that. 180 minus 104, which gives us 76 degrees. And that's going to give me, I'm going to do a different color here. In fact, I'll color it in green. That'll give me this angle right here, 76 degrees, which means the measure of the arc FE we know is going to be the same measure because it's equal to the central angle. I'll do it in blue over here. Okay, let's find the other stuff. And actually, you know what? We might as well label it over here. We got vertical angles. This is going to be the same as the one across from it. So this is also 76 degrees. And let's just label both of the arcs as well. 76 from here to here, another 76. All right, let's see if we can figure everything else out now. So the measure of arc DEF, carefully locate. So that starts at D. Then that goes through E and ends at F right here. Okay, well, there's a couple ways you could figure that out, but take a look at this. If this is a straight line going through the center, I already know that this is half the circle, so it's going to measure 180 degrees because it's half of 360. And if you weren't sure, you could also just add these together, but either way, you do get 180. Let's do blue. 180 degrees, okay? Next one, we want to find the measure of arc CFD. So let's locate that carefully. It means you start at C, you go through F, which would be this direction, and you end up at D. Now, probably the easiest, you have everything labeled, y'all, so we've made this real easy on ourselves. We could just add the parts together, this plus this plus this, boom, we got our answer. Or if you'd rather look at it as taking the whole circle, 360, and subtracting off this part, that will work too. Okay, so however you want to do it. I'm going to do 360 minus 76 because that's just less calculations. And that gives me 284. I'm going to write what I did off to the side on that one. I took 360 minus 76 to equal that arc. Okay, and last one here, we got the measure of arc DFE. Make sure you're doing this in the right order and you're locating it correctly. So it starts at D, goes through F, and has to end at E. So if we do that, D, we would go through F this way so that we could end up at E right here. And let's do the 360 method again. Let's do 360 minus the part that's not highlighted, 104. So 360 minus 104. And that is going to give us 256 degrees. They should all have degree symbols in the end. Okay, the only reason it's lengthy is because there's so many parts to it, which we have one more like that, and then I think the rest are pretty straightforward from there. So let's get through at number 4. All right, lots of stuff happening here. Before I jump into what it's asking me to find, I'm going to analyze some things. I notice I have a straight line right here, and I do have another straight line right here. So I might end up using those maybe for vertical angles, maybe for the fact that I'll use like the whole 180 thing. And if you want, start labeling things right off the bat. So I know, like, the fact that this arc is 25 degrees, I can solve for several things already. This will also be 25 degrees. And since we've got those intersecting lines that I just showed you, then these are vertical angles, so they're the same, 25 degrees, which means this arc is also the same, 25 degrees. So we've already found a bunch of stuff. We could probably find more and label it, and feel free to, but let's go ahead and see what they're asking us to find now. Okay, first thing, the measure of arc TQ. Okay, let's locate TQ. So T to Q would be this way. You might be thinking, well, can't this also be TQ? That would be a major arc, and if they wanted the major one, they would say something like TSQ. Right, or TRQ. They would label it with 3 points. So TQ is the small one, T to Q. Well, that's easy enough. We labeled it. We're going to do 44 plus 25, and that's it. So let me write that out here. I'll write it like directly out to the side. 44 plus 25 is going to give us this arc, which is going to be 69 degrees. Okay, good. Then it says find the measure of arc QR. See if we can locate that. Okay, so starting at Q, going all the way over to R right here. Well, we don't have this angle, but we can find it. There's multiple ways you could look at this. I would maybe pick one of those straight lines. I'm just going to pick this one, but it works with either. Okay, if I can highlight a line. There's a straight line, sort of. Hang on. It's hard writing on this sometimes. Okay, there we go. Which means from here all the way to here has to equal 180. So we can do 180 minus this part to get the rest of it. Let's do that. So we're going to do 180 minus the 25. So that's going to give us what, 155? 65, 75, 80. Yep, that's right. 155 degrees. That would be from Q to R. So if you want, go ahead and label that. I try to keep my things color coordinated, so I'll put a blue little arc there. I'll do green for the next one. So QR is going to be 155. Okay, great. Let's label it 155 degrees here. We also now know the angle right there is 155. Okay, let's see what else we got. The measure of arc TS. Let's see here. So from T all the way to S. That's a little bit tricky. Let's see how we could figure that out. Well, you got to be careful with vertical angles. I would have a lot of kids be like, well, isn't this across from this? Look at the lines though, okay? We will use that method, but look at where your straight lines actually are. And this one is kind of tricky to look at. So here's a straight line, and here's another straight line. So if you want to say what's vertical with this 155 would be this entire angle from here all the way to here. But we can totally use that, y'all. We do happen to know this little angle is the same as this arc. So let's label some things over here. This little angle right here is also 44 degrees, okay? And now if you look at how we had it highlighted, the straight lines, the angle vertical to this one goes from here all the way to here. Now if we want just this part of it, and we know all of it equals 155, let's do 155 minus the 44 to get the remaining part of that vertical angle. Hopefully that makes sense. That one's a little tricky. Okay, so we're going to do 155 minus the 44 part of that to get this angle right here, to get that angle. Okay, so 155 minus 44 is going to give us 111. And if this angle is 111 degrees, that means the arc that we're looking for from T to S is the same measure, 111 degrees. That one was tough. Okay, let's find the measure of arc SQR. So we start at S. We want to go through Q, so that's way over here, and end up at R. We've done several like this. Let's do the whole 360 method. So we can take all of 360 and subtract off this unhighlighted part. So 360 minus our 25-degree angle. Let's actually write that in here. 360 minus 25, so you don't forget how we did this. Was that the right angle? S to Q to R. Yeah, that's right. And that's going to give us 335. And we got one more left for this arc. The measure of arc RQT. So we're going to start at R. Let's see where Q is. Okay. We want to trace through Q and end up at T. So if we want that entire arc, the easiest way to do this, since we've carefully labeled everything, would probably be just to add the pieces together. We know this one, we know this one, we know this one. Let's add them up and we'll get the total of that arc. So let's write that out here. So we've got 155 plus 25 plus 44 will give us that entire arc. Let's see what we get. Plus 25 plus 44, that's going to give us 224 degrees. Okay, and that should be the last of the really lengthy ones. There's a couple more here that comes from that same section over central angles, but all they want is for you to find X. So let's dive into these. Okay, so whenever they say you have to solve for X, we know we're going to have to set up some kind of equation involving the information they're giving us here somehow. How could we do that? Well, it would be great since they're giving us, where the X is, they're giving us an expression for this arc. If we could somehow find this angle, we can definitely relate these things to each other. Okay, so let's try to do that. Now, if we know this is 31 degrees, obviously they're telling that to us to give us a hint. Well, that also means this this angle is 31 degrees. And we can use our properties of straight lines to find this part, because we know from here all the way to here is 180. So let's start with doing 180 minus 31, which, what will that give us? 149. Okay, so 149 degrees, and let's relate the angle to the arc. Well, what do we know about those? This is a central angle, which means it equals the measure of this arc. So we're in a good position now to just set this equal to this, and then we can solve for X. Let's do it. I'm going to put the 9x plus 23 on this side and then set that equal to 149. But it doesn't matter which way you do it. You'll still get the right answer in the end. Go ahead and solve that. So we would obviously subtract the 23 from both sides. I'll go ahead and show my work. I really should. So we get 9x equals... that's going to give us 126. And then, of course, we divide both sides by 9. And we get x equals 14. I guess I can write that down here. X equals 14. And then that's it. Okay, let's try to set up another equation with this one. Okay, this one is actually relatively easy. Take a look at the fact that we have straight lines. We love straight lines, because they create vertical angles. If this is 83 degrees, this is also 83 degrees. And if we know this is 83, we know that that's equal to this arc. So it's very similar to the one we just did. We're going to set this equal to this. I should have been writing that. It's going to all disappear. Okay, 83 degrees. But you know we can set the angle and the arc equal. So let's do that. 16x minus 13 equals 83. And let's go ahead and add that 13 to both sides. So we get 16x. I'm just going to skip that part. I think you guys can solve equations by now just fine. That's going to give us 96 over here. And then we divide both sides by 16. And so we get x equals 6. Okay, now you're done if you chose not to do the second part, the bonus part. So good job. I'll zoom out so you can see all of that. That's a lot of work. But if you did the bonus and you want to start working on or checking your answers here, then you can stay with me and I will work through these. Number 7. So now we have to shift our focus, y'all. We are not dealing with central angles. We are now dealing with inscribed angles. So be sure to watch the note video if you haven't already to work through these, or you won't know what I'm doing here. Okay, so let's see what it wants us to find. The measure of arc JML. Let's locate where that is. J goes through M, ends at L. Okay, well, I know the relationship is the arc is always bigger than the angle. Here's my inscribed angle, and it's always twice as big. So I need to take 88 and double that to get that angle. So I'm doing 88 times 2, which is going to give me 176 degrees. I'll write that right here. And that's it. That is the measure of that arc. Okay, try number 8. Okay, so here, very similar type of problem. You're just working backwards because they're giving you the arc and they want you to find the angle. So make sure you're going in the right order here. The arc is always bigger than the angle, okay? And so the way we go in reverse is we would take this and just divide by 2. So we're doing 34 divided by 2, which will give us 17. And double check that that's the right angle they want, angle ABC, and yeah, it is A to B to C right here. So 17 degrees. Don't forget your degree symbol here. Good. Okay, number 9. Of course, they're going to start getting a little bit trickier. Let's see what they want us to find here. The measure of angle WXY. Let's locate it. Here's W, here's X, here's Y. So you can see the angle that created is this one right here. That is what we want to find, which would be great if we knew this arc because it's an inscribed angle. And if we could find this arc, we could just cut it in half and get our answer here, get that angle. So let's see if we can make it our goal to find this arc. Now, that's not too bad actually, because you know all of the arcs in a circle add up to 360, and they give you the other 2 parts of it. So we can just add these 2 together, subtract from 360, and then we have that remaining arc right here. Let's do that, and let me write that math out. Let's do 86 plus 156, and I am just throwing this in a calculator for time's sake, and that's giving me 242. And then from there, I am subtracting that from 360. So 360 minus 242. Let me move this over a little bit. Oh, didn't want to do it like that. Here we go. 360 minus 242, which is going to give me 118 degrees. And that gives me this arc out here. Okay, so far, I know the arc from here to here. Now, it wants you to find the angle. So you've got to remember your relationships with inscribed angles, okay? It's not a central angle, right? It's not like at the center, so those don't, like that doesn't equal that. So it's very, or those would equal, but this angle doesn't equal 118, but it is half of it. So if you take 118, and you divide that by 2, we get 59 degrees for that angle. Final answer. Okay, let's try number 10. And then, yeah, a few more down at the bottom. Okay, we want to find the measure of arc RS. Unfortunately, it didn't say RT, or this would be super easy, right? So we want to find ultimately the arc from R to S. Okay, interesting. I don't know how to go directly to that answer, but and this is how a lot of geometry problems are. Sometimes you can't go directly to the answer. You've got to play around with the problem and find some other missing pieces, and then that will lead you to your final answer. So like one thing I know I can do is, since I am dealing with an inscribed angle, I can take this angle 42 and I can double it to get the measure of this arc, which might be helpful in finding the thing I'm actually looking for. So let's do that. 42, if we double that, that gives us 84 degrees. Okay, so that's from here to here, which I think will be very helpful, because if we want just RS, think about it. We know this part's 84, this part's 171. If we add those and subtract from 360, we will be left with the thing that we need. So let's do just that. Let's take that 84 and add it to 171. and that's going to give us 255. And let's subtract that from 360. So 360 minus 255, which is going to give us 105. And that would be the measure of our arc, 105 degrees. Okay, very good. And I'm sure they're going to get a little bit more complicated. I do see some algebraic expressions involved here. Let's try these ones out. Okay. I do believe we had some like this on the notes, so if you followed that, you're probably pretty good with these. And if not, make sure you go watch them. Okay, we do have an inscribed angle right here. So I know if I take that 67 degrees, I can double it to get the actual measure of this arc. And that's going to be a good starting place. So let's actually do that first. Let's write our work out to the side. So we're going to do, 67 times 2, which is going to give me 134 degrees. Okay, so I just found the measure of this arc to be 134 degrees. Okay, now they're not asking you to find the degree measure, they want you to find x. But what we can do now is we can set them equal to each other. I know that this arc that they gave me, this 16x minus 10, does equal 134 degrees. I just figured that out. So I am going to actually make my equation by setting them equal. So 16x minus 10 set equal to 134. And let's solve. Let's add 10 to both sides. We get 16x equals 144. And then 144 divided by 16. We're going to get x equals 9. And that's all they want is the value of x for that one. Not too bad. Okay, let's try 12. Let's see if this one is similar. It looks a little bit similar, except kind of working in reverse here. Because on this one, they give us the measure of the arc. They don't give us the measure of the angle. But it is an inscribed angle, so we know the relationship there. So let's start with taking our arc, which is always larger than the angle, and we can divide it by 2 to get that angle measure. And that's simple enough. 46 divided by 2 would be 23 degrees. And then we can go about it the same way. They label that angle as 7x plus 9, and we know the angle equals 23 degrees. So what do? We set them equal, and we solve to find x. So 7x plus 9 equals 23. And let's go ahead and solve from here. So we're going to subtract the 9 from both sides. And we get 7x equals 14. Divide by 7, x equals 2. So the algebra is usually easy. It's the geometry setup that's the tricky part. And it just takes practice. Okay, bonus time. If you want to stick around for it, let's do it. All right, what do we got here? Probably some multi-step stuff, but maybe it's not that bad. Okay, again, I think it's saying find the value of x. Yeah, we just have to figure out an equation to set up here to solve for x. All right, well, they do give us an expression there, and we want to somehow probably relate it to this big arc, right? Because this is, right here, this is an inscribed angle. Very wide one, but still, it's inscribed, okay? So it'd be great if we maybe knew the measure of this arc, which we can totally find because we know the measure of the other two. So we can add those together and do 360 minus them, and that will give us this remaining part of the circle. Let's do it. So we'll do 87 plus 39. What do we get when we do that? 87 plus 39. We get 126. And then 360 minus 126. It's going to give us 234 degrees. Okay, so we know the big major arc here, I can't really see where I'm going, there we go, is 234 degrees. And think about relating that to our angle right here. Okay, remember the arc is always way bigger than the angle. So when we go in reverse, we want to divide the arc by 2 to get the angle. So 234 divided by 2, if I want to write that out, or is our next step, 234 divided by 2 is going to give me 117 degrees, and that is the measure of this angle, 117 degrees. And we can do like we did on all the other ones now, set the expression they give us for the angle equal to the actual angle and solve for x. So 5x plus 2 equal to 117. Let's go ahead and subtract the 2 from both sides, which we're going to end up with 5x equals 115. And then we're doing 115 divided by 5. I'm not going to show my work, so I can keep everything in here. But that's going to give us 23. X equals 23. Very good. Okay, hopefully bonus number 1 went well. Let's try the last bonus one here. All right, similar type of problem. Ooh, this is a little tricky. Let's start by maybe finding some things that we can find pretty easily. Like for instance, they do give us an inscribed angle. So remember, we can actually double that angle to find the measure of our arc. So let's do that. Let's take 59, multiply it by 2, which is going to give us 118 degrees right here. Okay, now let's see what we can do. Well, you've probably already tried this one, so I'll walk you through my thought process. I know this is 75. I know from here to here is 118. I'm going to go the 360 method. I'm going to add these together and subtract from 360. So let me write that out. I'm going to do 118 plus 75. 118 plus 75, which gives me 193. And let's do 360 minus that. Let's see what happens here. Maybe you know the direction I'm going with this. So we get 167 degrees for the remaining part of the circle, right? So the 167 is going to be from here to here, the remaining part of it. Well, that's where the expression is. So we know that expression has to actually equal 167 degrees, so we set them equal to each other. 17x minus 20 has to equal 167 degrees. Let's go ahead and solve. You'll add your 20 to both sides, so we get 17x equals, that would be 187, and then 187 divided by 17 is going to give us 11. X equals 11. That one was a little bit tricky, but hopefully that went well. I'll scroll out so you can see everything, and I will see you on our next note video. Good job, y'all.